Welcome Astronomy 101 students. This video is going to be introducing us to gas giants. What are the different gas giants? What are the ice giants? What's it like on a gas giant? These will be taken from sections 11.2 and 11.3 in your OpenStax book. Just a little bit of background to get us started. So the gas giants are going to be Jupiter and Saturn. The ice giants are Uranus and Neptune. We've known about Jupiter and Saturn for a really long time because you can see them with your naked eye. In fact, right now, fall 2021, you can see them. They're some of the brightest things up in the sky in the evenings right now. So those have been around since ancient history. Uranus and Neptune are a little bit harder to see, and they are credited to these guys down here at the bottom, Herschel and Gall. Sort of interesting story there that once we found Uranus, so Herschel found Uranus 1781, it was predicted that there was another planet because Uranus's orbit wasn't quite perfect. And we thought there was something else tugging on it. So people looked for it for a long time, and finally it was spotted and given a name as our 8th planet in 1846. Speaking of names, you might wonder how Uranus is pronounced. I included a short little video in the playlist just with a few astronomers talking about that. That name is actually derived from the Greek Oranos, so you can call it that, I guess, if you want to be fancy. Okay, so that's just an introduction. Look for those planets in the night sky. If you have a telescope, you can see moons around them. So there's some of the really, really beautiful planets. All right, so let's get started. This is section 11.2. And we're going to talk about the giant planets. So as I was saying, Jupiter and Saturn are what we call gas giants. That tells us a little bit about what they are made of, right? And we're going to spend some time talking more about what the interiors are like, but they are primarily made of gas and liquid, hydrogen and helium. So primarily gas and liquid, and we'll talk about some of the interesting properties of liquid hydrogen and helium. So we've talked about in this class the protoplanetary disk, these light gases, and this is hydrogen. Oh, I left out the gin. Hydrogen and helium. Those are light, volatile gases, but they were able to form these planets out in the colder part of the outer protoplanetary disk. This is kind of an odd picture here, obviously not a real picture, but it illustrates an interesting point. Gas in these giants is not very dense. Saturn is less dense than water. So Saturn would float, which is kind of cool. Saturn is less dense than water. Of course, it would be really hard to find a body of water big enough to put Saturn in. But that just gives you a visual to remember that these aren't like Earth. Earth is very, very dense. All the terrestrial planets are. These are entirely different, these gas giants. Let's introduce ourselves to the ice giants. Those are the pretty blue ones, Uranus and Neptune. Okay, so Uranus and Neptune are ice giants. I think I call it Uranus just because that's what my teacher called it. I don't know if that was on purpose or what. Anyway, Uranus and Neptune are called ice giants, but don't think that they are only ice. They still have a mix of gas and liquid as well as some solids mixed in. So these are still made of gas and liquid, primarily, honestly. But we call them ice because they contain solids of heavier elements, not just hydrogen and helium. This is sort of showing that they are different and they are more dense. So they're still made of gas and liquid, but also more heavier elements and molecule substances. Okay, more heavier elements like, not like, because it's not elements, more heavier elements and ices, solid ices. Here's the like water and methane and ammonia. I'm not going to write all those down. So we still have gas and liquid. We still have some hydrogen and helium, but they are really different. You have these heavier elements that change the composition, change the color, change the look, change the density. So these guys are also more dense than the gas giants. So don't think they're a frozen ice ball. That's the wrong impression. Instead, sort of more of a slushy. Maybe that's not quite right either, but more liquidy than solid ice. So that's our introduction. We're going to sort of dig a little deeper. First thing is to understand that these guys don't have terrestrial surfaces, no solid surfaces on any of them. Even the ice giants, not solid. No solid surfaces. And they all have some things in common. They all have an atmosphere, so to speak, a thick gas atmosphere. And under that, most of them are some kind of liquid. That they have a thick liquid layer. So you might imagine it as an ocean, and we might even use that word because we don't have a better word, but really it's part of the planet. It's not separate from a continent. It doesn't really have a surface like an ocean. You just sort of move from thick gas into thicker liquid, and it's weird. It's different. It's not what we think of on Earth. So we have to keep that in our head. So one way to kind of talk about that is that the layers kind of all merge together. That these layers merge into denser liquid, and maybe as you get to the core, a solid. Denser liquid or solid in the core. Some people think definitely have a solid rocky core. Others think it has rocky type materials in these planets, but not quite completely solid. Not like we would think of. It's a very different environment down there. Pressure is different, temperature is different. We're going to talk about some of those things. So just sort of have to think of this gradient of gas to liquid core that may be sort of more solid, increasing in thickness and density as you go down. Okay, so we do have a couple of clicker questions. These will be on Moodle as a Moodle quiz, so find them there, answer them there if you need the credit. And that is it for this video. Go on to the next one.